Alrighty, in this video we are going to be talking about area between two curves. To find the area between two curves, we're going to use the same approach that we did with Riemann sums, where we're just going to slice up infinitely many rectangles to find the area. We need two things though. Where do the curves intersect, and which curve has the higher value? So we're going to talk about that whenever we graph number one. So here, we want to find the area bounded by the curves of 2 minus x squared and x. I'm going to graph x, since that's the easiest. And then I'm also going to graph 2 minus x squared. That's going to be your simple baby parabola. So it looks something like this right here. Now, what we are going to do is find the area bounded by the curves. So it's going to be this purple region right here. And we are going to slice up infinitely many rectangles, going from left to right. Now, since we're going horizontally, this is going to be in terms of x. So it's in terms of x, my bounds of integration are going to be in terms of x. So I'm starting at -2, and then I am ending at +1. Now, whenever we are thinking about my height of each rectangle, my height is going to go from bottom to top, or top to bottom. So it's going to be the difference between whatever my top function is, and then the difference between my top function and my bottom function. So whenever we are dealing with area in terms of x, we will always do top minus bottom. So in this case, the top is going to be f of x, and then my bottom is going to be g of x. So I have -2 to 1 of 2 minus x squared minus x dx. And then once I do that, I am going to integrate and then use my bounds of integration from -2 and 1 and evaluate. I'm not going to evaluate. Hopefully by now you know how to plug and chug in terms of FTC. But I will give you the answer of 9/2 units squared. So verify that 9/2 units squared works for number 1. Same thing with number 2. What we are going to do is graph x squared plus 2x plus 1 and 2x plus 5. I'm going to graph 2x plus 5 first. 1, 2, 3, 4, 5. Just because that's a simple linear function. Now, it's also important to note that on the AP exam, you'll obviously not be given graph. So you might have something like this where we might need to sketch something like this, like number 3, but we'll do that later. So here, hopefully by now you know that x squared plus 2x plus 1 is the same thing as x plus 1 squared. That's just me putting it into vertex form. Gonna graph that. And your parabola should look something like this. All right, and then I'm going to find the area of this right here. Now, because we are slicing up infinitely many rectangles right here, from left to right, this means that I'm going to use my x values. So my bounds of integration are going to be -2 and +2 in terms of my x values. And then I'm looking at my top function minus my bottom function, since I want the height of each rectangle. So in this case, it's going to be g of x minus f of x. Since g of x is first, that's my linear function. That's on top. Minus x squared plus 2x plus 1. And then my f of x, aka my parabola, is at the bottom. All right. That's going to be the setup. And what you're going to do is just make it pretty first and then integrate it. And then once you do that, you should get an answer of 32 over 3 units square. Make sure that you know that it's 32 over 3. So make sure that you know how to integrate and all of that stuff. Now, number 3 is pretty interesting because right now, 1 and 2 focused on one part of the region. We only had one part. For number 3, you have 2 regions where we want to find the area of between the 2 curves. So we want to find this area, and then we want to find this area. Now, one thing to note is our emphasis on top minus bottom. Right here, my top is going to be this cubic function right here. And then my bottom is going to be this parabola for my first region. That's not going to be the case for my second region, because if you look at the second region, my top is going to be my parabola, and then my bottom is going to be my cubic function right here. So it's going to be very important for us to distinguish between my 2 regions right here. So if I were to look at region 1, I know that it's going to be f of x minus g of x dx. And then my second region is going to be g of x minus f of x. Now, the only thing that we really need is going to be my bounds of integration, aka where my intersections are, so that once I make my rectangles going from left to right, I could see where I'm starting and where I am stopping. Well, in order to do that, since we don't explicitly know from this graph right here, we are going to play the game called set the 2 equations equal to each other and then find your intersections. All right, the negative x squares will eventually cancel out, so you're left with 3x cubed minus 10x is equal to 2x. The 2x can be moved to the other side. Then I could factor out a 3x, so x squared minus 4. That's going to give us x is equal to 0, x squared minus 4 is equal to 0, or plus or minus 2. So I have intersections at negative 2, 0, and positive 2. So looking at this region right here, my first region, my bounds are going from negative 2 to 0. So negative 2 to 0. And then my other bound is going from 0 to 2. At this point, I'm not going to give you the answer, and I'm going to stop here. Hopefully by now, what you're going to do is just integrate this and integrate this, but making sure that order matters, because this is f of x minus g of x. You're going to do 3x cubed minus x squared minus 10x minus negative x squared plus 2x. Because this is g of x minus f of x, you're going to do negative x squared plus 2x minus 3x cubed minus x squared minus 10x. All right, so this is basically an introduction to top minus bottom whenever you have dx. Now, if your differential is dy, and in this case, we haven't talked about that, that's going to be very similar, but instead of top minus bottom, we're going to do right minus left, which is going to be the next video.